Hey everybody, this is a video for my 40 Intro Calc students, and today we're going to actually start a lesson. Part 1 of the lesson is going to kind of put together chapters 2.8, 3.1, and 3.2. If you're wondering why we're skipping 2.6 and 2.7, it's because they will actually make their own unit that we'll do next. So we're actually looking at what's called higher derivatives, velocity, and acceleration, and that literally kind of translates to 2.8, 3.1, and 3.2 in your booklet. So today we're going to focus on 2.8, higher derivatives. So we'll call this part 1 of the lesson. And let's start with this basic rule right here. If f is a function and f primed is its derivative, we can find f prime primed, the derivative of the derivative. And that's what we mean by a higher derivative. It is the next level of derivative. And remember, if I'm going a little too fast here for you, you feel free to pause the video to catch up on the notes. So, in other words, if I take function f of x and I differentiate it, I will get f primed of x. If I take f primed of x and I differentiate it, I will get f prime primed of x, and after that I'm going to say etc. You can take derivatives of derivatives if you like. And let's not forget we also have our old friend Leibniz Notation. And in Leibniz Notation, here's what higher derivatives look like. The first derivative is this, and our second derivative, so get to our second derivation, looks like that. You actually put the squared after the d and before the y, but then you put it after the x. I honestly don't remember why that is the notation. Somebody explained it to me once, but I honestly don't remember it. Oh yeah, I guess I kind of do, because remember, you actually don't need a y. You can say the derivative of x as literally without an f for function or a y. You can say it like that. So when I say the second derivative, I put a second here, but I put a second there. That way, if I add an f or a y, it goes after the squared. I know, weird stuff. Okay, moving along. One more kind of note thing, and then we'll hit some examples. F primed, or f primed of x, or again, d by dx, or dy by dx, are called first the derivative of a function. And if I wrote f prime primed, or f prime primed of x, or again, the one we just looked at, d squared y over dx squared, those are called the second derivative. There are actually other notations besides these, but that's what I'm going to stick to in this course. There's ones that use capital letters and stuff, but those are pretty rare out in the wild. You don't see too many textbooks using them, so I'm not going to bother with them. So there we go. There's the notations and the basics of the notes. I think it's time to do some examples. So let's do example number 1. And example number 1 will be, let's see, we will do, how about this guy? Let's use our fancy notation first. Find d squared y over dx squared if y equals x to the power of 6. So, the solution will be, first, let's find dy by dx, the first derivative. First derivative is, use my power rule, so that'll be 6x squared to the power of 5. So that means dy squared, oh, see, I put it in the wrong place. D squared y over dx squared is equal to the derivative of this, which will be 30x to the 4. And that's all there is to it. Example 2, something maybe a little more challenging, and word it differently so you get used to different wordings. Find the second derivative of f of x equals 5x squared plus the root of x. Okay, what's our first step when we're encountering a radical? We change it to a fractional power. There we go. So there's step 1. All right, step 2, first derivative. Let's use the f primed of x notation this time. So that's 10x plus 1/2 x to the negative 1/2. Now, at this point, very often I'd start simplifying that to get rid of the negative exponent and the fractional exponent, maybe go back to radical. But I'm not done yet. That's only the first derivative. I want the second derivative. And the second derivative is, of course, going to be just 10 plus negative 1/2 times the half that's already there times x to, and now think about it, if you subtract a 1 from negative 1/2, that's going to be negative 3/2. Okay, and tidying that up a little, if the question doesn't mind, if the answer key doesn't mind that you leave this in a rational exponent or a negative rational exponent, it would just be negative 1/4, right, 1/2 times 1/2, x to the negative 3/2 plus 10. But if the answer key didn't want it left in that notation, you could write this as negative 1 over 4, oops, that's a funny looking 4x to the 3/2 plus 10. Or, well, there's all kinds of directions I could take this answer. I could say I want this simplified into one thing, in which case I'd times top and bottom by, I guess I'd times top and bottom by, let's see, what's the common denominator here? 1, so I'd have to times this by 4, so I could have 40 x to the 3/2 minus 1 over 4x to the 3/2. That might be the answer they're looking for. My hand just froze. There we go. I'm back. And again, I could have just taken this one and done something like, say, it's negative 1 over the square root of 4 times the square root of x cubed, which is actually x root x. And then what if they wanted the denominator rationalized? So I think I'll give up at this point. All of these are all the same answer. So basically you have to be ready to take a look at your work and look at the answer in the answer key and say, oh, do I have the right answer? And of course, listen to the instructions. The instructions will probably say, kind of like our last quiz did, what kind of an answer it wants. Okay, so that's enough of that. Let's get back to some actual calculus stuff. Example 3. Find f prime primed of 1 if f of x is equal to 3x cubed minus 2x squared plus x plus 5. Interesting, that. Okay, so first I'm going to have to find f primed of x, and f primed of x is going to be 9x squared minus 4x plus 1. Remember, the derivative of a constant is 0. And f prime primed of x is going to be 18x minus 4, because again, the derivative of a constant 0. So f prime primed of 1 is 18 times 1 minus 4, which is 14. Cool. So there's example 3. Example 4, let's do a third derivative. Example 4. Find the third derivative of y primed equals, y equals x to the power 4 plus 2x cubed minus 5x squared plus 3x minus 4. There we go. Sorry, I'm writing kind of sideways. There we go. Let me move that up to give you a second to copy it. Find the third derivative of that marvelous looking function. Okay. How do we start that? Well, why don't we start by saying y primed. First derivative is 4x cubed plus 6x squared minus 10x plus 3. Remember, the constant goes away. And then this constant's going to go away. So that's going to be 12x squared plus 12x minus 10. And then, oops, forgot my other primed. And then that constant is going to go away, because in the third derivative, I'm going to get 24x plus 12. And then that's my final answer. And remember that what is the derivative again? Oh, yeah, it's the equation of the slope of the curve, right? Anywhere that you're on. So technically, a second derivative is the slope of the slope curve, and so on and so on. And in our next lesson, we will actually look at some real-world examples of where you would use that kind of thinking. And of course, we're going to do physics because the booklet kind of sticks to physics. So that's where we'll pick it up for part 2 of the lesson. Thanks, everybody.